Kia ora. Here I'm going to try and show what happens when you add a common ion to a system that has an equilibrium. So what I'm trying to show here is I've got some sparingly soluble silver chloride, which is in equilibrium with its silver ions and chloride ions that are in solution. So although this should be all one big beaker, I've done the silver ion and chloride ions when it's present as a solid, on the left-hand side as a reactant, and the ions on the right-hand side as a product. Now, just using these values to plug into a Ks, just to show what's happening, is if I have 2 silver ions and 2 chloride ions, I could sort of say my Ks value is 4, because I multiply the concentration of my silver ions with the concentration of my chloride ions. But what happens now if I add a common ion? So I'm going to now add silver nitrate to the system. So here I've added silver nitrate, and I've added another 3 silver ions and some 3 nitrate ions. So if I try to put these values into my Ks expression, I now have 1, 2, 3, 4, 5. So that would be 5 over here, times my 2 chloride. So my Ks would be 10, which is not correct because in this example, we've made it 4. So we have to get rid of some of these ions, and that we can form when we go towards the left-hand side, the solid. We can only form silver chloride. So we need to remove some silver ions and some chloride ions. So the reaction goes and reverses to form the solid, and I get rid of some chloride and some silver. You can't get simply rid of positives without some negatives, so I've removed a chloride and a silver. And if you now look at my Ks value, it's now at equilibrium because my silver ions are now 4, 1, 2, 3, 4. My chloride ions, I've only got 1, but 4 times 1 is 4, the same as that one. So it is an equilibrium, even though I don't have the same number of silver ions to chloride ions, and that's just because I have added a common ion. My silver and chloride ions are now not only from my solid, I have also added from another source. So just be aware of that. So from Le Chatelier's principle, as you add more silver ions, the equilibrium position is going to shift to the left to form more solid silver chloride. So we're saying for Ks to stay constant, when I increase the Ag+, the Ag+ needs to be decreased to try and get rid of that increase. But if I decrease the Ag+, I am also going to be decreasing the chloride ion concentration. So I hope that makes it more understandable. Kia ora.